Hi, this is Anis and me Wenjin's second video for our Calculus 2 video assignment under Mr. Pova. When we are doing integrations, we face problems when we come across this kind of equations or functions because of the square root and we cannot integrate it. This is when we use trigonometric substitution to get rid of the square root, and in this video, we will be explaining to you about trigonometric substitutions. There are three basic substitutions that we must remember. X equals to a sine theta, x equals to a tangent theta, and x equals to a secant theta. We will also need to know the triangles for these trigonometric functions. For x equals to a sine theta equals to x over a. So here we have our right angle triangle and this is our angle theta. Since sine equals to opposite over hypotenuse, this is our x and this is our a. So by using the Pythagoras theorem, we can figure out that this is the square root of a squared minus x squared. And we do the same for x equals to a tangent theta and x equals to a secant theta. We determine which trigonometric function to substitute into the equation to be integrated by comparing the equation to these three. For example, if we have to integrate 1 over square root of 4 plus x squared, the bottom part we can rewrite it as square root of 2 squared plus x squared. We can see that it is in the form of square root of a squared plus x squared, which is similar to that of x equals to a tangent theta. So we'll be using x equals to a tangent theta for the trigonometric substitution. Okay, so now we'll be using an example, which is the integration of square root of y squared minus 49 over y with respect to y, to explain how to do the trigonometric substitutions. First, we compare and determine which trigonometric function to use. We rewrite square root of y squared minus 49 into square root of y squared minus 7 squared so that it's easier to compare. By comparing this part of the equation, we see that it is similar to that of x equals to a secant theta, which is square root of x squared minus a squared. So we'll be using x equals to a secant theta, where the x equals to y and a equals to 7. Now we have y equals to 7 secant theta. Next, we differentiate y equals to 7 secant theta, because when we substitute the trigonometric function into the equation will be in terms of theta, and we'll have to integrate it with respect to theta. So the differentiation is 7 secant theta tangent theta, where dy equals to 7 secant theta tangent theta d theta. Now that we have y and dy in terms of theta, we substitute the values into the equation, and we simplify it. As we mentioned earlier, we do trigonometric substitutions to get rid of the square root. Now we can identify a problem is with the square root of secant squared theta minus 1. We know that tangent squared theta plus 1 equals to secant squared theta, and so tangent squared theta equals to secant squared theta minus 1. Now we substitute this into the equation and we get the integration of 7 tangent theta times the square root of tangent squared theta. The square will get rid of the square root, and so now we have the integration of 7 tangent squared theta d theta. The square root is no longer our problem, but then we still cannot integrate tangent squared theta. However, we know that the integration of secant squared theta equals to tangent theta plus c, and that tangent squared theta equals to secant squared theta minus 1. So we combine these equations together by substituting this into the equation, and we can integrate secant squared theta by using this formula. So finally, we have our answer as 7 times tangent theta minus theta plus c. I made a mistake here, it should be minus and not plus. I'll correct it soon. But we cannot stop here yet, because our question is in terms of y, but our answer now is in terms of theta, so we have to change it to be in terms of y. Now, by using y equals to 7 secant theta, which is the trigonometric function which we use, we again draw the triangle and to figure out tangent theta. Since tangent theta is opposite over adjacent, tangent theta equals to square root of y squared minus 7 squared over 7. Then, from the same equation, we derive that secant theta equals to y over 7, so theta equals to arc secant y over 7. Now we can substitute these values into the equation. and I'll correct my mistake, which the plus should be minus. And so finally we have our answer. Thank you very much for watching our video. We hope it helped, and I'd like to thank Mr. Pova, Anis, Layla, and Nick Sheng for helping out. Thank you. Bye.